Welcome to the Tech Arena Data Insights webinar series. I'm Allison Klein, and we have a really exciting topic for you today. To get us started, I just want to introduce our host from Solidigm, Janice Narowski. Hey, Janice, how are you doing?
Hi, Allison. I'm great. Thank you so much for having us on the episode.
So, Janice, why don't you go ahead and introduce the topic for today and who are our exciting guests from Solidigm?
Yes. So today we are focused on Solidigm, which is exciting, and we will be talking about optimizing AI workloads and how Solidigm is achieving this by taking a look at the critical role of high performance storage from core all the way to edge. And our two guest speakers that we have today is one, Ace Stryker, who is Director of Market Development for Solidigm. And then we have Scott Shadley, who likes to go by being just our Solidigm evangelist.
That's
So
amazing. Welcome,
Get to
Ace and
talk a
Scott.
lot,
It's
so
great to
why
see
not,
you.
right?
So let's just get started. AI, huge topic of 2024, and I think 2025 is going to be really defined on how organizations are actually integrating AI capabilities into core applications. When you look at this, what are you seeing in terms of the tangible business impact that enterprises are looking to tap from investment in AI? Scott, why don't you start with that, and then Ace can add his thoughts as well.
Okay. From a business impact perspective, you look at what's going on in the AI space, and you can almost tie it to your favorite, analyst view of things like Gartner cycle or something to that effect, where today we're sitting with the rise of AI and we're hitting the top, right? So everybody's been willing to throw anything and everything at AI. And there's been a bunch of recent announcements about changes and developments and re-architecting requirements to actually kind of simplify what we've over-designed to some extent. And that's kind of what I see is looking as we go into 2025 is we're past the throw anything at it phase, and we're now heading towards how do we truly optimize this for long-term use point of view. And that's kind of what I see is happening as we start this year off.
awesome. I couldn't agree more, Scott. I want to toss a question over to Ace now. Ace, can you tell us a little bit about, what role does storage play in enabling AI workloads and, specifically how is Solidigm, positioned to address these challenges?
Sure. Yeah, it's a pretty simple equation, right? There is no AI without data. There is no data without somewhere to put it, right? And that's where Solidigm comes in. So the hardware infrastructure is a key part of determining the quality of model outputs, determining ultimately the business impact that these companies can realize by deploying AI. And it turns out not all storage is the same. And a little bit of understanding about what makes one drive or one solution different from another can have large consequences and drive, all sorts of beneficial outcomes for business. We don't expect our customers to become storage experts, to eat, sleep, and breathe data infrastructure in the same way that we do. But high level, as we look at what folks are doing in the AI space, we keep hearing about the same kind of care about items over and over from customers. Those are things like GPU utilization. So I just spent all this money, laid out all this cash for these highfalutin accelerators from NVIDIA or others. How do I make sure I'm getting the most I can? Because you certainly don't want to starve those for data, right? That slows down your whole pipeline and can waste a lot of energy and money. We hear about things like energy efficiency quite a bit in this context, where there's really at this point existential questions about, the grid globally and its ability to sustain AI at the current pace of development. We've got to find ways to do that more efficiently, right? There's all sorts of scary prognostications about how AI data centers are going to consume more power in the coming years than, giant countries. And you take your pick. Every tech CEO or analyst has said something along those lines. And so one of the important levers that you can pull to start solving that problem and optimizing for power is around density and storing more data in a single drive. That means, all else being equal, there's fewer drives in your AI cluster. That's less power, that's less space, that's less cooling, right? And so there are ways to realize efficiencies with the other components in an AI hardware cluster. But what we're hearing from customers is that storage is really kind of the easy button to do that, right? It's a lot easier to, for example, replace legacy infrastructure built on mechanical hard drives with SSDs and see an immediate bump in your performance and in your efficiency than it is to try to squeeze a little more efficiency out of your GPU or your memory or your networking or other parts of the stack. So those are a couple of areas where we see storage playing a really important role as we look ahead into a world where models are just getting more and more sophisticated, more and more capable, and ultimately relying on and generating more and more data as we go.
You've laid out a really good case that storage should be a prioritized focus for modernization of infrastructure for AI. And you said, not all storage is the same. It's also true that not all environments are the same. And one of the areas where we're seeing a lot of focus for enterprises is adoption of AI at the edge, where a lot of data resides and where a lot of application delivery is delivered to customers. One thing that I have a question for you, Scott, is how do you see Solidym's portfolio evolving to directly influence those edge environments and deliver unique infrastructure that supports edge?
That's a very good point, Allison, about the unique infrastructure. So one of the biggest challenges we see as we move to the edge is the footprint that exists for that, right? So the edge has been defined by various different people as near, far, endpoint. You pick your term, but the point is the whole concept of edge is that it's not in some massive data center sitting in the middle of an old cornfield, right? It's somewhere sitting on a street corner, or in the case of kind of playing off of ACE, the energy space, it's in a substation and things like that. These systems are restricted and constrained in a lot of ways that people aren't really thinking about. So the edge is where the data starts. And we need to get all that data. And it's even been shown that up to 83% of that data is not even touched because we can't move it where it needs to go. And so part of what we're doing with our portfolio of drives is to be able to store all that data, talking the 122 terabyte drive, for example, large footprint of data storage in a very small envelope. And it's not because we can't put a whole bunch of these in a system, but the systems at the edge don't support the same type of scale. So if you're in a data center, I've got a 2U24 chassis, I can put 24 of these drives and I've got petabytes. I'm sitting at the edge, I've got a half or 1U half short pizza box type server that holds maybe 4 drives, but I'm generating more data at that spot than I am in the core. So how do I properly manage that, get the performance I need and the capacity point that I want? And keep in mind that half the time, none of those boxes support a GPU. So I got to find new ways to innovate with the storage and the memory and the CPUs that are in the box to work together to actually satisfy some of those application workloads you're talking about, because we can't put the same level of performance in some of these environments and edge points.
Yeah, and to your point, Scott, we've got to kind of look at all of it, right? We've got to address, the capacity issue. We've got to, address the environment to which this new box is being placed. And, legacy storage, right, has been a very big challenge, and hard disk drives do still rule the world, but they're, really becoming legacy and looked away from, right, as some of these edge and AI workloads become more intense. So I want to ask, maybe both of you guys have comment here, but Ace, maybe why are traditional HDDs really insufficient for today's AI workloads? And then how do these new all-flash solutions, such as some of the Solidigm SSDs that are coming to market, help to overcome some of these limitations?
Sure. Yeah. Let's start by acknowledging there's always going to be use cases for hard drives. I don't expect them to disappear off the face of the planet anytime soon, right? In terms of kind of CapEx cost efficiency, they make a great case for themselves. But when you look at where we're headed with AI work and kind of the workload demands associated with model development and deployment, a couple of gaps emerge if you're relying on hard drives for kind of your storage needs in an AI cluster. One of them is obviously performance. So hard drives are limited by the physics of a rotating platter, by the SATA interface that they connect to the system with. And particularly when you look at random performance, which is reading, lots of little bits of non-contiguous data. That's again kind of in the weeds technically, but what we're getting at here is that happens to be a kind of work that training AI models relies heavily on. It tends to be a very random read intensive workload is kind of the term that we use for it. There is a huge gap between what a mechanical hard drive is capable of and what a solid state device can do. And we're not talking, 3x or even 10x. We're talking, thousands of times faster for random reads. Because there's no moving parts in an SSD, right? It's all electronic, whereas you physically got a CCAD in a hard drive that's going like this as fast as it can to try to read random data. For those who can't see the video, I'm wiggling my finger as fast as I can. That's what's happening in the hard drive, right? And so there is just a fundamental limitation to a hard drive's ability to do something like random read activity really fast, which, I talked about GPU utilization earlier. That's the kind of thing you'd never want to train directly from a hard drive because your GPU would be idle so much of the time. We do see hard drives still used quite a bit for kind of the object storage or what's called the data lake, this big massive storage that sits usually attached over the network outside of the GPU servers. So even in setups where you've got a bunch of hard drives doing that, typically you have SSDs in the GPU box itself. But as we look at the network attached stuff, that's where if you're training some big foundation model or even fine tuning on top of one, you may have, terabytes or petabytes of data sitting there. Lots of people today opt for hard drives in that case because, again, it's a cheaper kind of cash outlay up front. But a couple things happen over time. One is you still have that performance gap. So when you do need to read from that and transfer data into your GPU servers to do work, to manipulate it and make AI happen, you're waiting longer for that to happen. But also the density becomes the difference between hard drives and SSDs at scale becomes really, really important. Because not only can an SSD hold a lot more data, Scott mentioned our 122 terabyte drive that we just announced in November that's coming to market here soon. I think the biggest widely available hard drive today is 30 terabytes or so. So that's like a 4x difference, but it's also physically much smaller, right? A hard drive is like a 3.5-inch form factor. I'm struggling for an analogy of what that would be about the size of maybe a small, a small brick, right? Whereas SSDs in the U.2 form factor, which is what our 122 terabyte product is initially launching in, is like a deck of cards. So not only is it holding a lot more, it's doing it in a lot less physical space, and so you can fill up racks and racks like Scott was talking about with hard drives, or you can do it in a fraction of the space with SSDs. And so performance and density are really two of the things I'd point to answer your question, Janice, about kind of the shortcomings of hard drives for AI workloads. There are others. We could go into details around endurance and reliability and things like that. But I think the two drivers when folks are considering, what kind of storage do I want to deploy in my AI cluster are really those two.
I'm going to jump out of sequence, Janice, to 8, and we can circle back to 5 with your next question.
Yes.
So you brought up a really important point there, Ace. And I think that, one of the things that we've written about on Tech Arena is that the migration to 122 gigabyte drives is really a tipping point in terms of mass scale migration from HDDs to SSDs. When you're talking to customers, how do you scope the full TCO benefits that they should be thinking about from that type of migration across the topics that you talked about, power consumption, space, cooling for AI systems? And what has the response been in the industry?
That's a good question. And TCO modeling is a fairly complex topic. I don't want to bore our listeners by going into too much detail here, but we have developed a model internally in consultation with a lot of our customers to try to really get at what are the key variables that affect TCO in the context of like an enterprise's decision to deploy AI over, say, a 5-year time horizon. And so we look at things like the upfront cost of the hardware, but we're also looking at power consumption over time. We're looking at the cooling requirements associated with those storage choices. We're looking at duty cycle, which is a fancy term that just means how often is the drive busy? Because a drive that may ship with a 25-watt active power rating, for example, is usually only at that power rating a fraction of the time. It's usually at idle a lot of the time, which is potentially 5 watts, so much less. So the more performant the drive is in general, the lower the duty cycle will be. That kind of stuff feeds into the TCO analysis. So we think about reliability, we think about what's the annual failure rate, we think about all these things are comprehended in the model. And as far as the part of your question about customer reception, I think it's been positive because it's useful to illustrate that the obvious choice, which is let me kind of, go for the option up front with the, lowest dollar per gigabyte for my storage solution, is not necessarily the optimal one in the long term. That's not intuitive for a lot of folks until you comprehend all the various variables that play out over a 5-year period. So we do have ambitions, by the way, at some point, hopefully this year, to make public a version of that model that folks can play around with and plug in their own assumptions and plug in their own factors, right, and sort of run that analysis themselves. But it's been a very useful tool for our own kind of strategic planning and product development, and has by and large really aligned with how our customers think about things over the period of time after they deploy an AI solution as well.
Yeah, and calculating, power, just looking at the overall TCO, but really calculating power has become a pretty, no pun intended, hot topic, right, Ace? But I wanted to maybe ask, and again, both of you guys may have some thoughts on this, but maybe we'll start with Scott. It's been said that 80% or more of our, AI power consumption is coming directly from inference rather than training. So, how is Solidigm addressing the storage needs specific to inference?
Yeah, I think to your point, and to leverage kind of what Ace was talking about, the idea of the perfect model, right? Whether it's the perfect AI model or the perfect TCO model, doesn't really exist. So it's a matter of understanding the use cases, to his point, and to the duty cycles and things like that. So when you talk about the fact that the rest of the system is driving so much of the power consumption, you got to kind of look at the ratios too, right? So how many GPUs, how much memory am I going to sit in the system versus how much storage do I need to go alongside it? And to kind of spin back, sorry, to the hard drive aspect of it, right? The idea that you can do two things at once with an SSD. You can read and write versus a hard drive where you can read or write. All these things impact the ability to look at that analysis of how to find the right solution. So having a breadth of products and not just a single point solution, and have it as a family of drives at that. So you can have someone come in and pick something up that's fast when you need it fast and smaller density for these little servers at the edge that need the instantaneous access for inference and things like that versus these large drives sitting back in a cloud data center somewhere. So building a solution set that works across that portfolio and being able to allow customers to pick and choose the right drive for the training or the inference or whatever the case may be. We're going to continue to see the AI workload, and whether it's a trainings heavy, inference heavy, and where that power manipulation is going to happen. That's part of the optimization I mentioned earlier, right? And being able to give customers the right choice around that without saying, well, I only have this one drive that can do this one thing. I have what is your problem? Let me help you solve it. By the way, I can find a different way around that, that way of looking at it. So if I'm restricted by physical space, I'm going to start looking towards a larger drive that can give you more localized storage that you can manipulate it more effectively at that local point. If I have a whole bunch of space, I can do a whole bunch of faster drives and be able to do that inference much faster. So it's a matter of understanding that and not talking to a customer about bits and bytes, but talking to customers and their customers, right? Because not everybody that buys from Solidigm is the end customer. They have customers of their customers, and understanding the kind of work that's being done or needs to be done to address that and pick the right solution to address that power for inference, power for training, power for whatever the case that object may be that you need to work on.
Now, we've talked about the opportunity with high capacity SSDs to really reshape infrastructure decisions. We've talked about cloud to edge computing. One question that I have is, how do you see the shape up of that landscape in terms of the innovation of AI infrastructure and moving from a centralized compute to distributed computing model? Ace, do you want to comment on that one?
Sure. This is a space that is just moving at light speed, right? So I'll give you an answer today. By the time, this episode airs, it might be a completely different answer. And 2 weeks beyond that, it might be a completely different answer, right? As we record, we're in the kind of the throes of this market upheaval around this DeepSeek stuff that's going on, and people are trying to make sense of how real is this? How exactly was this accomplished? And and so forth. And so it's a very dynamic space. I heard a guy from Meta at a conference last year. He said last week was a very busy year in AI, which is something I think we can all relate to if we work in this space, right? But things are changing quickly. The name of the game here is really understanding at a fundamental level what are the drivers of a successful outcome, for an enterprise seeking to deploy AI, and building toward those. When I started working in this group at Solidigm and focusing on AI early on, I talked to a guy who's said something really illuminating to me, which was, we're not really reinventing the wheel here in terms of storage requirements. The things that have always mattered still matter for AI, right? We still need high random read performance. We still need security. We still need density, right? It's just that maybe we need these things more urgently now. Maybe we need them in boxes that serve a different purpose now. But at the end of the day, like the fundamental commitment to those things that really drive the outcomes that enterprises are looking for when they say, it's time and we're integrating AI and it's going to solve our business problems or help us solve our business problems. That's where the conversation really starts and ends for Solidigm. And, one of the things that I've been really grateful for in my time at the company is the closeness of the relationships with customers who teach us about these things all the time. We have, of course, our own point of view. We have our own labs. We're doing our own sort of pathfinding and planning all the time, but there's no better source for information as we seek to, sort of skate to where the puck is going to be than working with the best companies in the business. And we've been very fortunate in that regard to have access to the best and brightest minds who can inform our thinking and our planning. And together we can kind of look at these wild developments as they fly at us at light speed. and try to make the best, most informed, most strategic choices we can about what the market's going to need later this year, next year, the following year.
Well said, Ace. And that is what this episode is really about, right? It's really about what is Solidigm doing, but to your point, what are our partners and our customers up to? And we are going to take the opportunity to sit down with some of those partners and customers throughout the first and second half of this year. So everyone can stay tuned for the next episode to learn, to Ace's point, how are our customers enabling AI in a different and unique way, and probably changing every day. But with that said, I do want to ask you guys, looking ahead into 2025 and beyond, how do you guys see the evolution of AI impacting our storage requirements, and what role will Solidigm play in enabling efficient AI compute?
If I look at it from a perspective of what we see coming down the pipe, right? I kind of mentioned it a little bit earlier. We're looking at this time to optimize the architectures and not think I can just throw massive amounts of money at it. I mean, let's take a look to Ace's point about what the market did after this big announcement of doing it, quote, better, cheaper, right? It tanked quite a bit of stock because people are like, oh, wow, money's going elsewhere. Those types of things are important to think through as you evolve this into 2025, because there's also only been a few names in the space really that are talking very large about the big two letters, right? AI. We're going to start to see that expand and evolve and grow, and so our opportunity to have that impact and the visibility that Solidigm has at the lower level customer set, really. I mean, yeah, I want the big fish, don't get me wrong, but there's only so many big fish in the sea. There's a whole bunch of little sardines or other fish that we can go after that are already talking to us and know what we're up to and think that we have some great opportunity together. And so as we see the cost structures evolve and we realize that we can't really afford the tens of dollars per gigabyte of memory, but we can afford the tens of dollars of terabytes of storage to help better optimize all that, it makes a lot of difference in the marketplace. And I think that's one of the things we're going to continue to see. I was at a conference just earlier this year where they were talking about, to be able to drive the better models at the national labs, they're actually having to go dig into the archives and transmit data from punch cards and other old archive data onto solid state so that they can feed the models that they want to train with stuff like nuclear blast explosions. You can't do those anymore, right? No, there's no more testing out in the ocean, but that data is still valuable today, even though it's decades old, but they can't get it where they need it because the storage wasn't the right storage at the time. And that's where we're going to see some really cool evolution this year and into 26, with whether it be the ultra high capacity or the super fast. But either way you look at it, Solidigm's always been able to be there kind of right in time when the customers need it.
That's amazing. And I think that one of the things that you guys have shared is that there's so much opportunity for customers to take advantage of all of the technology, from infrastructure to core capabilities and applications. I can't wait to see it all. Before we leave, I want to ask you one final question, which is about Solidigm's product portfolio. Can you talk a little bit about how your products are addressing the different stages of AI workloads, from training to inference and from data center to edge, and how you're designing unique solutions to meet all of your customer requirements?
Sure. Yeah. So AI is not one thing, right? And we could go on at some length about this, but there are kind of constituent steps to doing AI work. You've got to take a bunch of raw data, you've got to clean it up into something that's usable for model training. Then you've got to train the model. And if you're doing a long training run, you should save your progress along the way periodically. We call that checkpointing. At the end of that, you've got a usable model, you'll deploy it, and someone presumably will use it to run inference, which is feeding it inputs and getting insights or outputs out the other side. That model at that point might be connected to other data sources in an approach called RAG, or retrieval augmented generation. Not to throw too much jargon at you in the space of 30 seconds, but then your work's done and you may want to archive everything at the end. And so understanding that there are discrete steps to this is the first thing to know. And then once you do that, you can kind of look at each one and say, all right, what's going on under the hood here? how busy is the CPU? How busy is the GPU? How busy is the storage? How busy is the network, right? And the answer is going to be different for each one of those stages. But as they taught us when we were kids, knowledge is power, right? And so you learn from a workload analysis exercise like that. Oh, okay, at the beginning when I'm just collecting a bunch of raw data, I don't necessarily need face melting, random write performance. It's more about density and efficiency and having enough kind of sequential throughput to get everything to disk. And oh, okay, when I'm training, random read performance is important, and writing those checkpoints, that's a sequential read. So again, we're going a little jargony here, but once you know the stages and you sort of know how an AI cluster is built, and the fact that storage lives in different kind of tiers within a cluster and serves different purposes, then you are armed to make smart choices, right? And so this is all laid out on our website. I encourage folks to check it out if they're interested in exploring this thinking more, solidigm.com/AI. But fundamentally, understanding A, what customers are trying to optimize for, B, what the stages of an AI workflow look like, and see, what those individual stages demand of a storage subsystem gets you to a point where you can have a really informed and useful conversation about storage choices. And then it turns out we happen to feel that Solidigm, like our portfolio, is a great fit for AI. We've put a lot of time and energy into making that the case. And so you can then map various things from across the product portfolio onto those different stages, for example, and say, oh, okay, like a high density drive built on QLC technology like the P5336, is a great solution for ingesting all that raw data up front. Or, oh, the Gen 5, sort of performance champion, the PS1010 is the right choice for training, right? There's a longer conversation to be had here to really get into the nuts and bolts of that. And again, we're available and our partners are available to help kind of guide customers through that journey. We don't expect you to get the storage PhD in order to deploy anything for AI. But it's a lot more useful to have that fundamental standing of the connection between AI and storage than it is to just make a decision on the basis of some spec sheet performance number or some dollar per gigabyte number, right? And so we do encourage folks to go a little bit deeper with us to try to understand, at least kind of on the second level down, what's happening, because it can, as I said up front, it can kind of swing your outcomes in terms of model quality, in terms of TCO, in terms of energy efficiency, quite a bit, by making the smart decisions when it comes to the data infrastructure part of your AI cluster.
That's awesome. Thank you so much for that. And thank you both to Ace and Scott for the great conversation today. It's been really insightful to see how the market is shaping up, including some of the latest news of new AI models from China reaching our shores. Thank you for your insights, and I think they're going to help guide the conversations that we're going to be having all year. Janice, any final thoughts from you?
No, thank you so much, Allison, for this opportunity, and I'm excited to see what we'll be talking about in the next couple of episodes.
With that, it's a wrap. Thank you so much for being here. And for those in the audience, please check out Solidigm's Tech Arena page for incredible content, and visit solidigm.com to learn all about the solutions that were discussed today.